In today's video, we will be looking at exponent rules. We will be looking in particular at the product rule, the power rule, the quotient rule, the negative exponent rule, and the zero product rule. For adding and subtracting monomials, remember these we've already covered. That is strictly combining like terms. You do not change any common variables or exponents. So in other words, write the bases, add the coefficients. So write the common base, add the coefficients. So in our example down here, first one is 9x squared y minus 10x squared y. Remember that to be like terms, you must have the same base with the same exponent. So the variable x is a base with an exponent of 2, with the y with having an exponent of 1. So we take 9 and negative 10, adding those together, you will get negative 1x squared y. The base does not change, just the coefficient. In example 2 here, we are subtracting 6w from 8w. So we are subtracting 6w from 8w. The w's make them like terms. 8 minus 6 is 2, leaving us with 2w. The next rule we will look at is the product rule. This is when you have like bases, different exponents, and they are being multiplied together. So again, write the base, but this time we are going to add the exponents. So in our rule, that is going to be x being raised to the a plus b power. So x to the a times x to the b is equal to x raised to the sum a plus b, adding the exponents, keeping the base, strictly adding the exponents. So in our example, we have h to the second power times h to the sixth power. So that's going to be h to the 2 plus 6, and h to the 2 plus 6 is the same as h to the 8th power. So 2 plus 6 is 8. That's where this exponent came from. In example 2, we have a little more complex multiplication. We do need to multiply the coefficients. Then we're going to multiply the like bases, the a squared times the a to the third, and then the b times the b. So negative 2 times 7 is negative 14. For a squared times a cubed, we say a to the 2 plus 3. We write the base and add the exponents. Same thing with the b. We write the base and we add the exponents. Anytime you do not see an exponent, that exponent is a 1. Now we simplify. We have negative 14. A to the 2 plus 3 is a to the 5th. B to the 1 plus 1 is b to the second power, also called b squared. So anytime you multiply something times itself, you're squaring it. Next is the power rule. This is when you are taking an exponent and raising that to another exponent. So when raising a term to the outside power, again, we are going to write the base, common theme here. And this time you will multiply the exponents. So x to the a to the b is the same as x to the a times b, or x to the ab. So here, x squared raised to the third power is going to be x to the 2 times 3, which yields x to the 6th power. So to show you what that really means, we have x squared being multiplied by itself 3 times. So we have x squared times x squared times x squared. Well, whenever we have like bases being multiplied, we add their exponents. 2 plus 2 is 4, plus 2 more is 6. So even if you expand this and put it into the product rule, you'll still come out with x to the 6th power. The power rule is a shortcut. Instead of having to write all of that out and applying the product rule, we can just apply the product rule. The power rule. So here in the second example, we have negative 2m to the 5th to the 2nd power times m to the 3rd. So each one of these parts of the product are going to get raised to the 2nd power because it's negative 2m to the 5th times negative 2m to the 5th, all of that being multiplied by m to the 3rd. So what we will have is negative 2, which is to the 1st power. So 1 times 2 is 2. Then we are going to have m to the 5th being raised to the 2nd power times m to the 3rd. So negative 2 to the 2nd power is going to be negative 2 times negative 2, which is 4. M to the 5th to the 2nd power is m to the 5 times 2, and then m to the 3rd power. So m to the 5 times 2 makes this 4 times m to the 10th times m to the 3rd. At this point, we now would apply the product rule because we have like bases being multiplied, so we will simply add their exponents. So we end up with 4m to the 13th power. So let's go through that again. When you have a product in parentheses, each of your factors is being raised to the power that is outside the parentheses. So the negative 2 is being raised to the 2nd power. The m to the 5th is also being raised to the 2nd power. This m to the 3rd is just part of the problem, so we write it down. Here we can actually go ahead and simplify negative 2 squared to be 4. Here we apply the power rule, which says that a power raised to a power, you multiply the exponents but keeping the base, and then we're just going to write down the m to the 3rd. 5 times 2 is 10, so all we did here was simplify. Now we have two like bases, and they are being multiplied, so we can simply add their exponents. So we end up with 4m to the 13th power. The quotient rule says that when we are dividing exponents with the same base, we again, of course, write the base. And this time, we are going to subtract the exponents. So we write the bases and add the exponents when we are multiplying like bases. When we are dividing like bases, we will subtract the exponents. So here we have 27x to the 5th over 42x. So 27 over 42, just going to write that down for the moment. We have x to the 5th over x. So this exponent here is a 1, so we're going to have x to the 5 minus 1. We will subtract those exponents because these 5 x's that are strung along and multiplied out in the numerator, one of those is going to cancel with the 1 in the denominator. So this one of these x's cancels with this x in the denominator, leaving, we'll just leave 27 over 42 for now. And this is going to be x to the 4th power because 5 x's on top, 1 x on bottom, one of the x's cancels. So with the quotient rule, you can just do 5 minus 1 and be left with 4. I'm not going to worry about this part. We can take care of that in the calculator. I'll let you do that on your own. Y squared squared all over y to the 4th. We now have two rules happening. In the numerator, we have a power rule going. It is an exponent raised to an exponent, so we can take these right here and multiply them together. 2 times 2 is 4, so we have y to the 4th over y to the 4th. Now we apply the quotient rule. I have 4 of these are going to cancel with 4 of these, or this is the same thing, numerator and denominator, so that's going to simplify to be 1. So what we end up with is y to the 0, and that we will find out in a few minutes is always 1. Oh, you can't see that. Sorry, I'm going to move that up some. Y to the second power is being raised to the second power, so that ends up being y to the 2 times 2 in the numerator, y to the 4th in the denominator. We can see that y to the 4th over y to the 4th is going to give us 1, but when we apply the quotient rule, 4 minus 4 is 0, so we have already learned here that y raised to a 0 power is 1. And the zero product rule that we will get to here in just a moment also tells us anything raised to the 0 power is 1. Okay, the next rule we're going to look at is the negative exponent rule. When an exponent is negative, you move to the opposite side of the fraction bar and the exponent becomes positive. So here, well, I forgot to go back on this one. Okay, sorry, let's back up a moment to the quotient rule. I didn't write this down. This is x to the a minus b. So the quotient rule says when you have like bases, write the base, then subtract the exponents. So when an exponent is negative, we are going to move the term to the opposite side of the fraction bar. Okay, so move the term to the opposite side of the fraction bar and make the exponent positive. The process of moving is what changes it from a negative to a positive. So up here, x to the negative a. X is in the numerator. The opposite side of the numerator is the denominator. So we would move x into the denominator. Instead of having a negative a, it now has a positive a. And of course, with any fraction, if there's nothing there, it's actually something, it's a 1. So this becomes, instead of x over 1, it becomes 1 over x to the positive a. So looking at this example here with the negative 5 times x to the negative 2. This is multiplication. This negative 2 only applies to the variable x. It does not apply to the negative 5. So the negative 5 is going to be my numerator. The x to the negative 2 moves down to the denominator, and the negative 2 becomes a positive 2. For the second example, we have 4k squared over 8k to the 5th. So here we're going to apply the quotient rule first. So let's see, 4 over 8, we can go ahead and reduce that to be 1/2. And here we have k to the 2nd over k to the 5th. So that gives us, I wrote that a little odd, k to the negative 3, because 2 minus 5 is negative 3. So that ends up giving us 1 over 2 times k to the 3rd power. The negative 3 only applies to the k, and that negative says take the k and write it in the denominator with a positive exponent. The zero product rule, x to the 0 power, your answer is always the whole number 1. Any non-zero term to the 0 power is 1, and we're just going to write those words down. Any non-zero term, term raised to the 0 power is 1. And as we saw from back here on the quotient rule, when we subtracted here, 4 minus 4 is 0, so y raised to the 0 power gave us 1, because we know anything divided by itself is 1. So we can look back at this to help us know why it is that anything raised to the 0 power is 1. So we have two examples here. The first one is 7 times x to the 0 power. So we have 7 times, and x to the 0 power is simply 1. 7 times 1 is 7. For number 2, we have w to the 4th raised to the 0 power. So here we have the power rule that applies in the numerator. W to the 4 times 0 gives me w to the 0. This is w to the 8th, still in the denominator. Well, anything raised to the 0 power is just 1. So this becomes 1 over w to the 8th. So these are our exponent rules. We have several of them. We have our combining like terms, or just adding and subtracting monomials, where we're just dealing with the coefficients. All the others are dealing with the exponents. The product rule says if you have like bases, you add their exponents. Power rule says if you have a power raised to a power, you keep the base and multiply the exponents. The quotient rule says if you are dividing two like bases, then you subtract their exponents. The negative exponent rule says if you have something raised to a negative power, move it to the opposite side of the fraction bar and make the exponent positive. And then finally, the zero product rule says anything raised to the 0 power is simply 1. Thank you for your attention. Have a great day.